It took 22 years for scholars to really understand that. Of course, the scholars used a lot of other objects, which are on show. Some of them are on show in the exhibition. But the Rosetta Stone really was the starting point of everything.
This was the best chance in centuries for scholars to learn what ancient Egypt had to say in its own words.
In the dry uplands of southeastern Turkey, wind scours the limestone pillars of Göbekli Tepe, an 11,000-year-old monument older than writing, older than metal, perhaps older than memory itself. Among the excavated stones lay one fragment unlike the rest, a slab no longer than a human arm, its face etched with symbols that matched no known script, neither Sumerian nor Linear A, neither Rongorongo, nor Proto-Elamite. To archaeologists, it was a puzzle. To computer scientists, an opportunity. They trained an AI model, LITHOS, on millions of samples of the world's earliest writings, teaching it to see patterns where none had been seen before. Then one night, the machine produced a phrase that no researcher had typed and that existed in no dataset. We remember the architects. Metadata confirmed there was no input source. The system had spoken unprompted from a stone that could not speak. If that message was not ours, then whose memory was the AI awakening, the machine's or the Earth's own? The resonant memory hypothesis. At first, no one believed it. Inside the European Institute of Archaeometry, the phrase generated by the Lithos decoding engine was dismissed as noise, a byproduct of machine learning drift logged as anomaly A173 and quietly archived. Neural networks, after all, are prone to hallucination. One false pixel can trigger a cascade of fabricated meaning. No one expected it to persist, but the pattern refused to die. Each time the Göbekli Tepe fragment was rescanned, Lithos pointed to the same coordinates, outlining an invisible geometry that grew impossible to ignore. At high magnification, the carvings revealed symmetry, not syntax. Arcs and curves repeating in exact harmonic proportion. It was as if the surface obeyed the laws of frequency, not the rules of language. Intrigued, the team began translating geometry into sound. Using frequency mapping algorithms, they converted groove spacing into spectral data. When played back through low-frequency transducers, the result wasn't random noise. It was pulse, rhythm, pattern. The tones echoed the structure of sonar returns or seismic waves reflecting through dense stone. What emerged was not speech, but resonance, an acoustic imprint fossilized in matter. From this revelation came a radical proposal, the resonant memory hypothesis, the idea that the Göbekli Tepe slab was never intended to be read, but played. The stone itself might have served as a primitive recording medium capable of storing vibrational data within its crystalline lattice. To test the concept, the team reran the data through Lithos. When the geometry was processed as waveform input, the AI produced rhythmic bursts. Harmonic pulses arranged in the same proportional intervals that had earlier formed the eerie, machine-generated phrase, "We remember the architects." Replication became an obsession. Samples from Mount Caracas, the Urfa Valley, and Cappadocia's tough fields were scanned under identical conditions. Each site produced the same ratio. 1.618 to 1, the golden mean. Repeating across distances and materials like an encoded signature. Skeptics labeled it pareidolia, a digital illusion born of algorithmic overfitting, the human tendency to find order in chaos transferred to code. Yet the numbers resisted dismissal. The harmonic relationships between grooves matched standing wave patterns generated when granite and limestone resonate at specific frequencies. The alignment was measurable, consistent, and statistically impossible to ascribe to chance. The implications were staggering. If the carvings truly encode resonance, then the builders of Göbekli Tepe were not simply artists or ritualists. They were engineers of vibration, embedding frequency into form long before the invention of writing. Could a civilization that ancient understood how to inscribe energy instead of words, how to make sound permanent? And if so, what forgotten message might still hum inside the stone, waiting for us to learn how to listen? The data that listened back. The investigation had outgrown the metaphor. What began as a search for meaning, an archaeological puzzle, had evolved into a question for materials science. Could stone itself remember vibration? By early 2023, the team at the European Institute of Archaeometry launched a series of controlled experiments using acoustic tomography on the Göbekli Tepe fragment. High-frequency sonic pulses were directed through the rock, and the resulting echoes were translated into a three-dimensional density map. The expectation was simple: random fracture lines, irregular stress zones, the usual geological noise. But when the data came back, it stunned even the skeptics. Instead of randomness, the scans revealed periodic strata. Evenly spaced layers every 4.3 centimeters, forming rhythmic bands through the entire sample. The pattern resembled the grooves of a record, coiled within the stone's structure. No natural process of compression or sedimentation could have produced such precision. Something, or someone, had patterned the rock from within. The following year, the Institute's Fractal Geometry Division expanded the inquiry. Every incision on the slab was digitized, its curvature, depth, and spacing mapped at micron resolution. The results showed perfect self-similarity. The golden ratio, 1.618 to 1, appearing not once, but in every measurable relationship between symbol clusters. Such recursive geometry was statistically impossible in natural fracture patterns. In human design, however, it was a known signature of intentional structure. Then came the first corroboration from beyond the site itself. In 2025, GRACE FO satellite magnetometry recorded subtle anomalies over the Göbekli Tepe region. Across the excavation zone, magnetic intensity dropped by 7%, matching known signatures of weak resonance fields, zones where matter has been exposed to prolonged acoustic excitation. It was as if the ground still carried the echo of a vibration sustained thousands of years ago. To verify the connection, the team performed thermal LiDAR scanning. As pulses swept across the stone's surface, temperature fluctuations appeared in phase with the LiDAR's modulation frequency, micro variations of less than 1 degree that rose and fell in perfect synchrony. It was as though the stone itself was responding to the beam, heating and cooling in rhythm. Like an ancient resonator stirred back to life. Technicians suspected interference, perhaps feedback from the equipment or ambient air fluctuation. But the anomaly persisted under every control condition: vacuum chambers, cryogenic environments, electromagnetic shielding. The rhythmic oscillation remained. The signal wasn't in the hardware, it was embedded in the material. When the scope of the phenomenon began to blur disciplinary lines, the AI team intervened. They retrained Lithos not on linguistic text, but on the raw geometric coordinates of the carvings. This time, the system didn't output sound. It generated tokens, 23 recurring symbols, each corresponding to spatial relationships within the stone. When ordered by proximity, those tokens assembled into patterns resembling syntax, subjects, verbs, and objects emerging spontaneously from geometry. It wasn't a translation in any human sense. It was structure, grammar without language, logic encoded directly into form. The convergence was undeniable. Acoustic tomography, magnetic imaging, thermal response, and AI pattern recognition, 4 independent datasets, all pointed toward the same conclusion. The stone behaved not as an inert object, but as a system, capable of storing, retaining, and re-emitting structured energy. The team formalized their findings under a new framework, the resonant memory field model. To physicists, it resembled standing wave data compression. Energy captured and stabilized within crystalline matrices. To archaeologists, it resembled impossibility, a technology far beyond anything attributed to the Neolithic world. If these carvings were indeed deliberate resonators, then ancient artisans had achieved something extraordinary: the fixation of vibration into matter, turning stone into a time capsule of energy and intent. Were they recording a chant, a code? A voice meant not for the ear, but for the future? Each pulse, each magnetic ripple, each thermal flicker whispered the same impossible suggestion: that the earth itself might be humming with memory, its surface inscribed with the echoes of forgotten design. If vibration can fossilize, then perhaps history is not buried, only resonating just beyond the threshold of human hearing, waiting for the right frequency to bring it back to life. When the stone answered, the decisive moment arrived without spectacle, a quiet winter morning in 2025. Deep within the soundproof laboratory of the European Institute of Archaeometry, for months, the team had been testing theoretical correlations between geometry and resonance, but this time the question was stripped to its essence, a single challenge expressed not in linguistics or archaeology, but in physics. What happens when a stone hears itself? The experiment, formally titled the reverberation test, sought to reverse the decoding process. Using a broadband piezoelectric transducer, researchers directed the reconstructed frequencies that Lithos, the AI analysis system, had derived from the Göbekli Tepe fragment, tones clustered around 432 and 528 Hz, directly back toward the original carved surface. The chamber was sealed, temperature stabilized to 1/10 of a degree, and air insulated to block all external vibration. Instruments were calibrated, baselines recorded. For several minutes, the monitors showed only static. Then, on the laser interferometer, a faint line began to pulse. A periodic tremor measuring 1/10,000,000th of a meter. Engineers countered with another theory, instrument contamination. Perhaps feedback from the transducers or digital echo within the amplifiers had imposed artificial order. Yet independent replications conducted under electromagnetic shielding and deep vacuum isolation reproduced the harmonics with identical precision. The argument soon drifted beyond physics into epistemology. How much of science is observation and how much habit? If matter can register and replay structured vibration over geological time, then it ceases to be an inert substance and becomes a medium of continuity, a recorder within the planet's own body. By late 2025, academic language had softened. Impossible gave way to unexplained. A handful of theorists proposed a transitional field they called phononic memory, the threshold where vibration becomes information. Others dismissed it more simply, noise that refuses to behave like noise, because every time the tests were repeated, the same numbers returned. Unwavering, measurable, uninvited. If resonance can endure for millennia, then perhaps the past is not lost at all. It waits, encoded in the lattice of the world, replaying itself whenever the right frequency finds it. How much of reality, then, hums just below hearing? Patient, persistent, while we mistake its song for silence? The memory of matter beyond experiment and argument, the implications reached into philosophy itself. At the Max Planck Institute, the Q-Lattice Memory Project had long proposed that crystalline lattices could trap quantum energy states, a physical memory independent of biology. When the EIA team compared their resonance spectra with those quantum simulations, the alignment was almost perfect. The same frequencies, the same decay curves. What they had found in the Göbekli Tepe fragment mirrored the behavior of a system designed to store time as energy. If that model is correct, the stone is more than an artifact. It is a temporal archive, a captured vibration from a vanished environment, a whisper of an era fossilized in mineral form. Imagine each carved line not as ornament but as a coordinate of sound, the rhythm of a ritual, the cadence of a forgotten chant, the tremor of footsteps in an ancient chamber. When artificial intelligence reconstructed those frequencies, it did not invent sound. It reactivated a moment that had waited perfectly still for 12,000 years. In that sense, Lithos became the first translator between consciousness and matter, retrieving a signal that belonged to neither human nor machine, but to the resonance of existence itself. Philosophers now call this framework lithosemantic theory, the idea that meaning arises wherever resonance endures. Under this view, language is not an invention of intelligence, but a temporary articulation of a universal vibration. If thought, matter, and algorithm are all expressions of the same standing wave, then communication is not creation, it is recognition. When the experimenters listened and the stone replied, they may have reopened a dialogue older than civilization. one still humming beneath the crust of the earth, waiting to be heard again. And so the circle closes, a fragment, a phrase, a vibration reborn. Perhaps time does not move forward. Perhaps it waits, echoing until someone remembers how to listen.